Hello, everyone. Welcome to today's session. Today we are revealing the unlocking data science and machine learning in just 1 hour. Like I said, my name is Alex. I'll be your MC for today. Before we kick off today's call, I noticed that we have some people entering the chat. This will be recorded. So for today's session, the chat is open, as you can see below. Everyone can discuss and sort of ask questions as we kind of go through today. However, as Kevin Clements is instructing, we may not be able to read all of them in real time, but please be patient. We'll ensure we save some time towards the end to answering any of your questions. Lastly, a follow-up email will be sent to everyone here today with the recording. If you are interested in receiving the deck for today, we can also send that out upon request. I'm going to include an email in the chat right now where you can save, and that will be who you can contact for receiving the deck as well. So with that, I'm going to go to the next slide, and I'd like to just take a moment to introduce who we are, Excel ILT as a company. In the next slide, actually, after this, we're going to kind of go through the three sister companies that we have. So Kevin, if you wouldn't mind going to the next slide, I'm going to try to break down what these three companies are. And, maybe you've come through one of these and kind of giving you some insight on the others if you're not familiar. So the collection of these three brands here, they kind of allow us to service the entire life cycle of employee technical training. We have ExitCertified, which is known for providing customized courses for teams and advanced tech and software application training that essentially enables businesses and teams of all skill levels to accomplish their project end goals. With ExitCertified, we actually provide authorized training from leading technology vendors, and we also offer a combination of official courseware, which is tailored to developing custom materials, and we provide clients with comprehensive education and industry-recognized certifications. With WebAge, we actually create upskilling programs for entire organization, upskilling and reskilling. So these unique specialized upskilling solutions are tailored to organizations' specific needs and goals. So like I had said, with these three brands, we kind of cover the entire life cycle, and we provide resources to sort of help teams and organizations alike meet the growing demand for professional development. With that said, a little insight on who we are, I'd also like to provide some insight on our instructor today. So Kevin, if you wouldn't mind going to the next slide, I'd love to introduce you. Kevin Clements comes with us with over 35 years of experience as CEO of Claremont AI. Kevin has a proven track record of helping organizations streamline operations, develop efficient strategies, and implement innovative and effective software solutions. With 3 decades of real-world experience, Kevin leverages his deep understanding of data science and ML to deliver tailored solutions. So with that, I'm really excited to pass it along to Kevin today. I'll be monitoring the chat as we go through the session. But with that, Kevin, please take it away for today's session.
Thanks very much, Alex, and good morning, good afternoon, good evening. And of course, if you're watching this from the previous broadcast, then welcome back, I guess. Our agenda today is to really give an overview of what data science and ML does for us, to give you some knowledge about that, where it can fit into your organization. We'll have some real world examples around that as well. And I'm going to do some live demonstrations of popular libraries as we work through this 1 hour session. So it's going to be very quick, but hopefully, the insights that we're able to give you today will allow you to understand what those possibilities are for your organization. And that's really what it's about. How can I use these technologies today to do better? And that could be in any different way. So we'll come down to that in a moment as to how that might fit for your specific organization. Right now, with studies being done in the past, I would say, year, we've seen, for instance, from CFO Drive, one of the major sites out there that keeps track of what's happening within organization. There's about 28% of the organizations in the US were using some form of AI, a lot of it based on ChatGPT, but more so in the data science realm and ML realm. In today's world, so as of about a month ago in the latest survey, that has increased to almost 65%. So there's been a huge uptake of these ideas and principles within data science and with machine learning for those organizations. That's a huge jump. And we kind of have to wonder, why is that jump happening out there today? And it really comes down to using data, right? If you think about data collection, that hasn't changed. We've been doing that for a long, long time. It's just the velocity of that data collection has increased, I would say, tenfold in the last 2 years in particular, since the kind of online work that's being done since 2002 by OpenAI. Awareness has certainly increased that. We haven't changed really the way in which we analyze data. In the past, we've done our prompts. You may know that term from ChatGPT, but we've done our prompts in SQL databases. We've utilized data that has been in some kind of table form and normalized for, well, 40 years. I've been teaching SQL for, I think, 30 of those years in the past, and we haven't really seen a lot of change in that. But what we've seen now is the requirement to do it faster. So analyzing data faster has become very, very prevalent. And there's a couple of reasons for that. If we think about cube data that sits in warehouses, we often have data that's over a series of years and it's structured in some way. We're taking that cube data and we're extracting it and pushing it to a new location. And often that new location is off of the on-prem environment and into some kind of cloud environment. There's a couple of reasons for that. I think the major reason for that change is the capabilities of the cloud and the capabilities of parallel programming. We know in the past, it's been very expensive to do this in an on-prem environment. Today, we want to make those informed decisions and create value from the data. That's really what the driving factor is here in business, to get insights as quickly as possible. And if we think about that in real world applications, from a healthcare perspective, we certainly want to get patient data quicker, right? The patient needs that information, especially if we talk about, cancer or other types of diagnosis where it's quite critical to get early and effective medical intervention. This makes sense. And so if we can understand, from a perspective of the patient, but also understand from the perspective of the institute itself, the hospital, what kind of cases are we being presented with? How long do those patients take in the treatment? And that, of course, results in beds and so on that are required by the organization. So this is a kind of a priority today, right? We want to get patient care, hospital costs down, so that we can treat more people quicker. In the case of finance, one of the big areas there today is fraud detection. Happen to work with a large credit card company that, this is their focus, right? Getting as quickly as possible that information so they can prevent it. It's increasing, as we know, in different ways, whether it's through phishing emails or other mechanisms, and robotic callers and so on. How can we use data science to analyze this and identify those problematic areas? And then finally, the last one that's mentioning there is marketing, right? So if you think about in the marketing phase, where do we see, that segmentation of our users, and how can we stop, that loss of or gain that retention of those users through understanding them better? So that's really where we want to tailor kind of the marketing information. So the purchase history, the online interactions, right? All of that information can be garnered to give us a good insight to that individual user, but also to be able to use something like k-means to understand the grouping, the clusters of those users and their interests. When we talk about machine learning, remember that it is a subset of AI, and we've heard a lot about AI, I'm sure, in the past month, if not the last 4 years. We want to focus on the development of these algorithms. I think there's a misconception about modeling and algorithms that happens in the industry. It's often, oh, we're going to get this model done and it's going to take us, this week and we're going to have this new model. That's actually problematic because that expectation is causing concerns in the data science area and in the machine learning area. Proper modeling and proper creation of an algorithm could take months, if not even a year, in a proper setting. So it's not something that necessarily is going to happen today. However, we could take pre-trained models that already exist and introduce those. That's going to help us speed up the time to generate a new algorithm or a new model for our specific use case. You have to think about where this comes from. Data science and ML is kind of a research area. So new models are generally created in that research realm. They're not generally created in the business realm and then released. We don't see that happening because you want to keep your proprietary algorithms and your proprietary models once you've created them. At the same time, we start to hear about AI security, AI explainability. Yes, that is happening. It's certainly being looked at by large organizations like OpenAI. Think Microsoft Copilot. Think Gemini from Google. AWS, of course, has their own proprietary models, but they work with other organizations to bring in these pre-trained models to help, of course, look at those and automate those complex processes. So again, what we're looking for from a business perspective, perhaps, is yes, we're seeing segmentation, but why are we seeing it? From the hospital care, why is the treatment for this patient higher than like patients that have perhaps the same disease or cancer or whatever it may be? Typically, what happens here is as these algorithms get better, we start to see more innovation. ChatGPT 5 is about to be released in December. The models there are claimed to be about 1,000 times more performant than the last release of ChatGPT 4 and, of course, ChatGPT Mini. That's going to be a next leap. If we think about Claude with Sonnet and so on in Anthropic's tools, again, we start to see these big leaps, but with smaller data sets for the training models. That's going to continue over time. So over time, we should see that increase. I've put in 3 types of machine learning kind of tools that are used, areas that they're used in, supervised learning, unsupervised learning, reinforcement learning. That's not the only ways in which machine learning can be used, but I wanted to kind of focus on the 3 major ones. These are effective areas that we can pick up very quickly and work with today, models that already exist. And that could be something like going out to, let's say we want to use pandas to start to prepare our data. So this is an example of a tool that we might use for that. I'm sure if you are a data scientist, you're probably already well aware of pandas. But there's a drawback, and a lot of people are not aware of that. When they start to prepare data, you can imagine, on your local machine, on your laptop, you probably don't have a lot of memory. You certainly probably don't have, many CPUs. And by that, I don't just mean, 4-core or 8-core. We're talking well over hundreds of CPUs to work with. And generally, we're not talking about gigabytes of memory. We're talking about, petabytes of memory that we can take advantage of. If that's the case, we do need to move to some cloud provider in order to take advantage of it. It's just too costly to go out and order those CPU and GPU for our on-prem environments typically. So we do slicing. And that's essentially the pay-for-go model, that you see out there used by AWS and Google and Azure's and others. I'm mentioning the top three, but of course there's other providers out there like Oracle and IBM that we could be using as well. Pandas is a fundamental library for creating data frames. Now, that sounds kind of weird, but in Python, we want to store the information in memory. So unlike what we would do in the SQL world, and by the way, you can still use SQL. We're not saying don't use SQL. And when you do, my company has patents with Adaptec. We'd love you to buy those RAID cards. But that's not, where we're going to stop. We're going to use both of these in combination. SQL is going to be used for the standard transactional data that we want to collect over time. And for some, we're still going to use it as the data warehouse. For others that need that faster insight, we're going to use Pandas here to manipulate the data and prepare it from our data warehouse, and we're going to move it into the cloud. Data frames essentially equivalent to tables. Not exactly, but let's leave it at that for the simplification here in the class. So we're going to equivalent this to sourcing our data, probably doing some kind of exploratory data analysis where we do ETL, extract, transform, and load the data. So once we have it prepared, we can start to process it. How do we process it? Well, as I said, we may take advantage of some of these models that are available to us that have already been prepared. So one of the big ones out there in the Python world, of course, is Pandas. And the second biggest one is likely to be something around what is called Scikit-learn. This is, again, a module that we would install, we would utilize effectively for, as you can see, creating classifications, working with some kind of regression, maybe a linear regression. An example of that would be, I want to know, is the house prices in my environment, in other words, in my community, going up or down? Is it a good time to sell? Is it a good time to buy? We know that interest rates are coming down, so we might want to do some kind of a linear regression and see how that's affecting the market. We could do clustering. I mentioned clustering earlier, where we're looking at segments of organizations. A good example is if I'm a company that's selling a product, I want to know what segment of the market is buying that particular product, and maybe I want to know that versus some other competitor, because that's going to show me where I might have a competitive advantage. So again, these are all different things that we can do. There's great examples that come with these packages. So for instance, if we wanted to look, at some kind of regression or some other kind of classification, we could certainly do that in a simple way and pull this, obviously into our program. We're going to look at a couple of these, but they will fit into these different areas. So if we want to do something where we're going to train the model ourselves and then we're going to build it out, that's a supervised learning. We may have the capability of working with unsupervised or unlabeled data. The difference between this is somebody has gone in the supervised learning, they've added labels to the data, they've looked and understood the data, and they've maybe even done some kind of manipulation to the data. We have to be careful with that for skewing and bias, but again, they've done some kind of insight into the data to allow us to make further acknowledgements through our model about what that data contains. In unsupervised learning, it's the opposite of that. We don't do any pre-processing of the data. We take the data in, we run a model to train against. There are many tools out there today. The AWS has SageMaker. Of course, Google has BigQuery that we can take advantage of to look at that data and come up with a solution. We actually call that AutoML. So if you've never heard of that, all it is that I'm not sure what algorithm is going to be the best, or what model is going to be the best to run against my data. So I'm going to say here, take this data that I have and let me know, and the system will go through and figure out what it thinks is the best model to use for that data. So AutoML is a huge area today that a lot of the cloud providers are offering for you as a starting point. We've got reinforcement learning. Reinforcement learning is about getting feedback and sort of updating the data. And by the way, in all of these realms, the models are going to change over time. It's not something that stays stagnant for a very long time because the data is continually getting updated. And as data changes, we need to ensure that the models are getting updated as well. All right. I think what we should do is maybe introduce you to some of this. I'm going to use kind of a neutral forum here for that, and this is something called Databricks. Databricks is one of the companies that was behind Spark. Spark is an in-memory data store. When we say that, what we're saying is that the data is not stored necessarily on disk all of the time. This is one of the problematic issues with SQL. You have to move the data from a hard drive into memory, and that process can take some time, the file I/O. In our case, we start to split the data into partitions that are running on different parts of the cluster. Now, this is the big difference between SQL and what we have here in this realm, and that is that it's not a single machine, it's a cluster of machines. So we might have 5, 10, 1,000 machines, depending on, again, the requirements for our data scientists and ML engineers to work in this environment with the size of data that we work with. We split the data up and we run the model against different parts of that data. Now, we can do some partitioning in SQL, as you're probably aware, but here we're talking extreme partitioning. And again, replication of data and so on as required. So no loss of data because we are running data in memory. We want to have multiple copies of it. And so we start to work through that. This is an example of working with Pandas and NumPy. NumPy is a numerical package for Python for more precision. We can load data in, and this is a small data set. Don't get me wrong. For these demos, I kind of have to do a small data set so that we can actually understand what's happening here. Imagine that this is an extraction of patient data. There could be hundreds, millions of records easily about patients at a particular hospital. We've kind of boiled it down here as an example, and in our training programs, we often do this, where we take, real data and we extrapolate it so it's more understandable for you when you're attending. Here in the first example, you can see that we've pulled in some data. Doesn't probably mean a lot to you, right? Doesn't probably mean a lot to you. I think you could probably figure out that there might be, some kind of row ID. You can probably figure out that maybe this is the patient ID. We've got some dates here. They happen to represent when the patient came in and when they went home, essentially. And then the number 4 row represents the case that they presented with. So the type of disease or maybe cancer that they had at the time that they were in the hospital here as a patient. We want to, of course, create that then as essentially a table. So this is that idea of the data frame that I mentioned. And you can see here as I highlight over it, it gives me some insight on how I can create that information effectively here for storing the data in what is going to be essentially the data frame called patient. We then can look at the information. So again, this would be like when you do a create table in your relational database. We can do something very similar here, and we can produce data with data types. And that's essentially what we are showing here when we print the schema that we've just generated. You can see the row ID is a long. Long just represents an integer value. Again, we've got some string values represented. The string represents the dates that were shown there. We could have made those a date value as well, but it really depends on what we're trying to do. If we want to show some of the data in those rows now, we can do so. And as you can see, it's been organized in the way that the first column is the row ID, the second one is patient ID, and so on. We can count how many records there are. Again, I said it's a smaller data set, so about 1,000 records, but this could be millions. It doesn't really matter for the training purpose. It just makes it simpler for us to understand. We can start to build functionality where we split the data out and we pick the columns in the data that are important to us. And again, this is going to be essentially that labeling idea that I talked about a moment ago. We want to figure out which columns are the most important. We will then extract them and we'll start to use them in a way that makes sense. We may even change the names. As you can see here, we've got some aliases, and anybody that has experience with SQL would certainly understand. An alias is just to give it a new name in some cases, or in our case, we're using the same names, but we're splitting them out and we're creating a new data frame, essentially. So we've gone from DF underscore patient to DF underscore patient 2. We haven't thrown away the original data. That's still here in memory, but we're going to create a subset of it that we can start to work with more programmatically. And that's really going to be the key term here that we're going to use. The key term is programmatically. Because we are writing a program essentially here in our Jupyter notebook in Databricks. So what does that mean? Well, it means that we can start to do queries that allow us to understand information. So here we can understand when the patient was admitted and when the patient went home. How many days was that for the particular type of again, case that the presenter was presented to us by the patient. As you can well imagine, we've stripped out any PII here, any privacy information from the data sets, because that would be obviously problematic for us. But we are now able to see, based on the type of case that they came in, how long were they in the hospital. And some of these are quite considerable times. Again, that duration, we can look at the minimum duration, we can look at the maximum duration, we can look at the average duration. These are, again, problematic things that we would want to understand based on the data that we're working with. And so we start to do that here. We start to go through and collect all of the rows together. We start to write different types of filtering on the data. That's typical of what a data science or machine learning scientists would do to better understand what it represents. Eventually, we're going to get to some kind of count of records of how many presented with this type of test case and so on. And you may have noticed, I didn't really point it out here, but you may have noticed I'm able to take that data that I've put into a data frame and actually extract it and put it into SQL. So I've now put it into an SQL table as well. Again, I don't have to do that, but it is something to be aware of. If I need to take this back and I want to put it into my SQL database, I can certainly do that. I don't have to take it out to Oracle or some other place. I can do that here in Databricks as well, because if they do support that. I can do that with RDS in the AWS world, Azure, of course, using something like HD Insight maybe, or as I mentioned, Bigtable in BigQuery in Google. So a lot of these environments allow me to work still with the data that I've been doing my programmatic work with in Python or other languages, and do a quick conversion to see what it might look like. That might be my ultimate goal, is to push that eventually to an SQL data store. Again, standard commands that you would know, perhaps in SQL, group by, we just have to happen to have it written a little bit different. So instead of being 2 words, group and then by, it's all 1 word here in our data frame for us to work with. And we start to group it in certain ways. So equivalent commands that we saw here can be done programmatically as well. And if we really want to start playing with it, we could look for the maximum duration. We could look for the minimum durations for the patient care. We could even do the average of the patient care time. And again, if you think about that from the perspective of the hospital offering care to patients, if I know what the minimum and maximum durations typically are, and if I know what the average durations are for that patient to be under the care of the hospital, this is going to be very helpful. It's not only helpful to the hospital, but think about this coming from an insurance perspective, right? How long do I need to have coverage for that patient? What's the maximum durations? What's the minimum durations? Now, when I'm offering healthcare through insurance programs, I could think about how I could adjust that as well for that type of care that's required. So again, this is where you kind of start into looking at modeling more of this information. There are many, many places today that we would go to find various models to start with. I mentioned about this, kind of idea from the perspective of building it out. But we have to think about how this actually takes place. So as I said, there are kind of steps, right? We collect the sources of our data. We start to cleanse the data. Now, in cleansing data, we need to think about what it is as well, because that could lead to us to introduce some bias, which we don't want to do in the data. So from a repairing data point of view, we kind of have to think about, well, what are we doing? And there's some steps that can be done in cleansing and repairing that data and in the exploratory data process. So again, we would look at that. This is an example of repairing data. Yes, I will deal with the where would I go to get models in a moment. So we'll talk about the e-commerce one and others. Here's an example, and again, I tried to simplify this as much as possible given the time that we have here in the class, so that you can understand how it could be utilized. We've got a very small table. It's okay. It could be thousands of rows, as I said before, but to understand it in the form that we're trying to do here, we've pulled in essentially some data and we've created some column names. Essentially, we could call these whatever we want. I've just called them C1, C2, C3, C4 to keep it very simple so that we can see how this works. If you start to look at the columns, for instance, here in C1, we have 1, 2, 3, 4 of the column rows that don't have any data. Now, you can imagine that could be problematic. If I try to start to analyze a column where half the data is missing, it's not going to give me very good results. So through the EDA process and through that data cleansing process, I may decide that C1 is not very good data to work with. And I could decide to drop that column altogether. So from our perspective of working with this, first off, we want to identify all of the null values. Again, we've got programmatic ways of doing that in Python. This is a quick example of using an isNull. And some of you, again, may be familiar. If you come from the SQL world, we use isNull and isNotNull all of the time. So it equivalates to what we're doing here in the Python realm. We can see C2 has 1 missing record. We can see C3 has 2 missing records. And we can see C4 has 3 missing records. So we've got about 60, maybe 65% of the data here, probably about 80% of the data here, probably 95% of the data in that. And then, of course, about only 50% of the data in column C1. So the idea would be to drop that column. So not going to use it, let's drop it. So you can see very quickly we can remove items from the data set. Again, we're not losing the original data set. It's still going to be there in memory. We're creating a new data set here of the data that we will work with. And that's essential to, again, if something goes wrong, we need to go back to the original data set for this exploratory data work. We can do that, right? It's still there in memory. We can still work with it. Again, you can now see that we have 8 rows and 3 columns. So before we had 8 rows and 4 columns. Now we have 8 rows and 3 columns. We could start to test in a particular row if we wanted. For instance, here, axis 1, where are the rows that have missing data? So here, row 1 has 1, row 2 has 2, and so on. And we may decide to even drop axes that way and remove them. But more likely, we don't want to do that. What we probably want to do is fill in missing data in some way. And there's a couple of ways of doing that. Actually, there's about 17, but a couple of ways that we're going to talk about here in the program today. And so the first way would be to look at the interpolation of the data, trying to figure out, maybe we want to work with the nearest neighbor to basically take the value from the column above and stuff it into the missing column. That's one way of doing it. Again, we'd have to think about biased and any kind of skewing that we might do with that, and we would report that in our final report so that everybody is aware, right, of the bias or skewness of that data presented by us repairing it in some way. But that's a simple way of taking the nearest value and stuffing it in. So here in column 4, where it was missing some data, we are stuffing in the value from column 3. So you get the idea. Another way might be to take the mean value and stuff it in. So this is another example of doing that. So here, filling in column 3, the mean value of the column, which would be 43 there. Again, we've got different ways of working and repairing the data as required. Once we get it to a certain state, though, we could start to do more work with it. Again, it would depend on what we're trying to do. So this is an example of using Scikit-learn, pre-processing the data, identifying, and maybe even having to scale the data that makes sense to scale it. So it's going to be easier to understand the data when we work with it. But those would be certainly the starting points of our processing to get it into some format, and then we're going to start building the model. So going back to the question that I saw in the chat about where can we get models today, probably one of the biggest places that you would go is Hugging Face. Hugging Face offers, I think today there's over 1 million models that have been uploaded to Hugging Face. Organizations like OpenAI, any of the ChatGPT components will use a lot of these. You'll see other organizations using them as well. In fact, Hugging Face has its own chat using one of the most prominent models today. It's a 70 billion model. So 70 billion parameters were entered there. ChatGPT 4, by the way, just to let you know, has 1.7 trillion parameters that were used for training the model. So it's not something that gets trained in hours, as we said, or even in a week. It might take months to do that. So ChatGPT 4 came out in March. ChatGPT 5 is going to come out in December. You can see that there is a definite time frame between the new models and the new versions of those models being available. It's not something that happens overnight. It's not to say that it can't be something that happens in a very, very short period of time. As I said, if we work with some of these pre-trained models, we take them into consideration, and then we probably are going to add our own data to do that specific training that we want to return the information that is fine-tuned for the information that we're working with in our organization. I've just used a couple of terms there that I now want to explain. So fine-tuning is about working with your data set basically tokenizing the data. That term is essentially breaking it up into smaller data sets. In the terms of ChatGPT, it's breaking the words up into individual words and vectorizing them. That just means creating a matrix of it. Back to our model here of the cube, it's a matrix. See, and then going in and understanding the data through running these models, so training the models, testing the models, validating the models. And that, as I said, that process can be sped up when we do go out to model sets like this. So one of the questions is, where can I find a model on e-commerce? So, well, just type in e-commerce. We spell it right. There are lots of models that we can work with on e-commerce here from Hugging Face. So you just have to go here and search for the type of model that you're interested in. Now, that's not to say that there aren't other places that you can go for models as well. There's lots of competitive areas out there. Kaggle would be another one. So I'm sure some of you have heard of Kaggle and the Kaggle tools. There's Kaggle competitions, of course. Again, we'd want to be cautious on some of these things because this is more of the bleeding edge, the data science areas where people are doing, high level machine learning models and building it out. But again, depending on the size of the data set that you have, you could start small and build up. You could start on-prem with your own laptop, desktop. Again, I want to caution about that, and there's a couple of reasons that I want to caution. One is if I'm running Pandas, if I'm running some of the NumPy libraries and Scikit-learn libraries locally on a laptop, I'm not taking advantage of essentially clustering capabilities. While I can produce something, I'm probably producing it, on a smaller data set. Let's say, a couple of gigs of data, because it's just not going to be efficient. I need to move to either an on-prem environment that has been set up, and it could be GPUs. NVIDIA, we have partnerships through ExitCertified that teach NVIDIA training. The great partnership there. We have partnerships with AWS, where we can go into things like SageMaker, Glue notebooks, and we've got the ability to go out to Google with Google GCP and some of those tools and do training through those areas. So it's going to really depend on your organization and what tools you can use. All of our trainings take advantage of a lot of those, so it's up to you to kind of decide, where that fits in and what tool you as an organization want to use. But those are some of the major ones that we would start with. So pre-trained models that we can start with, and then going from there, obviously through the process, we could certainly speed that up depending on what we're trying to do. Popular algorithms, as I mentioned, linear regression, decision trees. It's really going to depend on what you're trying to evaluate through the model itself as to where you would start with your algorithm and the models. A lot of organizations have partnerships. So AWS has the marketplace that you can go to and partner with other organizations that are developing models and making them available. Evaluation, I would say, by far is probably the most important thing to think about for your models and the model sets that you're working with. And as I said earlier, we need to think about things like bias, the skewness of the data that we're working with initially. We need to bring that information through to the model evaluation so everybody's aware of it. We need to think about overfitting, where often we don't have enough data. We need to think about underfitting as well, where the model that we've chosen maybe is too simplistic for the outcome that we're looking at. But these metrics are going to allow us to kind of better understand, did the model that we produced accurately understand the data that we were working with, and has it given us enough information that we can trust what it's going to generate. Remember, the model and the idea of this model is to give us some kind of business insight. So, from that perspective, not research here, does that insight fit with what we want to do within the organization? If it doesn't, we're going to send them back, the data scientists and the ML folks back, and they're going to go back through and do more operations of it. So that's why it's not going to happen in a week. It's going to happen over a period of maybe 2, 3, 6 months that you're going to get proper insight into your business data, and you're going to be able to do something with that. It's the accuracy that we want, right? The accuracy is always about how correct is this model in what it's producing for us to be able to understand the business. Now I'm looking at it from a business perspective here, but we could also look at it from, government, and government data. There's no reason why we couldn't be, pulling our data from GovCloud for that matter. I've worked with a couple of organizations recently, where we've gone out here to the data sets and we've said, hey, let's look at it. You might be working with the US SEC, for instance, looking at some of the data that's coming from there, maybe the financial statement data set, download that, upload it into some cloud provider or run it locally, but trying to get some kind of insight into that data. Same as IRS. The IRS has some great data sets out here that you can look at. Whoops, it didn't come up when I clicked on it, but let me try that again because I tried to open it in a different model. Yeah, so it says I have to be given access to that. So I can't do that from this perspective here in class, but certainly we're working with government teams. We could certainly take that information and utilize it. One last thing I wanted to talk about with regards to that, and I've got some examples as well. So we've looked at, processing data here in the data frame. We've looked at repairing the data. I've got a couple of examples that I've done recently for training. One here, looks at the electric vehicle marketplace. And if you think about this, right, from a marketing point of view, what is it that I want to know when it comes to working with electric vehicles? I just have to rerun that, I think, to have it pull the data. There it goes. And so in this case, what I'm interested in is knowing, based on the population, how many people are actually buying electric vehicles and where's the most prominent area. So if I'm selling maybe accessories for electric vehicles, like plugs and electrical outlets and things like that, maybe I want to target that area because it's more prevalent. And I could also see from that perspective, where are the up and coming areas for electric vehicle sales. So if we start to look at some of the data here, you're going to see, Washington, you're going to see the different types of makes that people are buying in the electric vehicle realm. And, if we want to really get a good understanding of that, by the way, that's a very large data set that I pulled down. We could start to look at, again, the information in those data sets, maybe by postal code or by the model year that people have, right? Even, the particular model for that matter is available as well in these data sets. And this came from the data.gov site. So that's actually where that data has been produced and given to us. So we can start to, understand the data further, right? Model it in a particular way. Here we can see the uptake based on years and the projected uptake there for 2024. And you can see we've got no 2025 data, which makes sense. But certainly for 2024, we can see that data has increased dramatically. And that could be for many different reasons, right? We would want to look at, is it because of incentives that the manufacturer is doing, incentives that the US government is doing or the state is doing? It may be just the philosophy of folks in a particular, area, they've decided that it's important to hop into the electric vehicle area. So again, yeah, interest rates could be anything, gas prices, right? Yeah, absolutely, could be anything that's driving that. But the idea is that we can get quick insights and understand that for our particular industry. And a lot of times, it's that visualization that becomes important for the data itself. And I just wanted to talk about that quickly here. So we've got different types of plotting that we can do in the world and realm of Python. Notice that we're doing this right in the notebooks with the data that we have. So again, this is something that we want to think about. How does it work in unstructured data like network signals? Yeah, so there's actually some particular models that are available for that area. If you go out to Kaggle, there's been some really cool, again, from the data science perspective, from the research perspective, some really cool models that have been developed in that area. I actually had a conversation recently in a class where we were talking about network signaling specifically, and we were looking at some of the Kaggle models. So again, we can draw those in. We can start to discuss them in the programs that we're delivering. That's really why we're here. But I also want to mention, and as I have been mentioning, there's lots of other areas that you can look at as well. Lots of great books. Towards data science is not a bad place to go. Real Python, which is a great website today, has lots of great insights into things like data science. And even Google offers, some crash courses in this area for free. Of course, we've got the Web Age Solutions site listed there as well. And I know that Alex has got some things to talk to us about before we finish up the day. Let me go and see if there was any questions that I missed. I don't want to leave without trying to cover off some of those. I'll just hop back there. Algorithms, methodologies for multi-class, multi-labeling. Yeah, absolutely. So when you start to look at pre-processing data and things like that, Scikit-learn has some decent things to start with. But again, you're going to want to go out to most likely Hugging Face to look at specific models where you can start to do that multi-label classification, a lot higher than what I was just showing, the 4-5 columns of stuff. You definitely want to look for the models that allow and hyper parameter tuning as well. So after the fact, you may want to go and run additional parameters to see, if I take in this label, will it give me a better insight? So there's lots of them out there for that. I think I gave the link there earlier. So if you want to take a look at that. Answered the e-commerce one. How much of this processing methodology is used in structured data formats? Yeah, so all of it actually, and not just older XML and CSV stuff, but we're talking about processing today that can be interconnected in real time to things like Kafka. We can work with Avro data. We can work with JSON data. So one of the insurance companies I work with, that's what they're doing. One of the other ones that I'm working with work with real time on data processing of credit card data. So again, those data sets are very specific and very specific for the industry. So yeah, any formats that you want to use are there. You may need to convert it, right, by going in and figuring out the columns that are important, the labeling essentially for you. But transitioning that, you can work with SAS in Python. There's a direct connector for SAS. There's a direct connector for SQL. There's a direct connector for pretty much anything that you can think of there. And if not, you can go to things like Kafka that provide that interconnection. So Confluent and allow it to be streamed through Kafka and Kafka KSQL data store. I teach all of these classes, so that's why I'm just mentioning them. Apache Storm will do this. So there's just Flink So there's lots of tools there to transfer the data in and start to utilize it in our realm here. But yeah, unstructured data is a pretty common scenario for any of this because that's what we deal with, right? My world, I didn't even mention that, but I come from the controls industry where life safety is critical. So our data is coming in as streamed points, right? With information like did that turn on or turn off, right? So that's a kind of a binary signal. This is going to be different because it takes CO, it gets other information for the fire alarm. And then it becomes extreme because if you think about life safety, let's just talk about in a data center, right? I can't flood the data center with water. There's thousands of batteries in there. It's the same problem Tesla has, and that will cause fire, right? So what I have to do is I have to use halcyon, but I can't use halcyon because it will kill the people that are sitting in that data center. So all of these considerations have to be made. So we need to monitor through RFI, some kind of way of knowing that everybody has left that sector of the data center before we flood it with halcyon to put the fire out. And this goes into fire trucks today, right? You probably haven't even thought about this, but in your community, your city has to think about how are we going to fight fires that are electrical fires in vehicles as electric vehicle increases. Now we got to have a specialized truck, and we have to place those trucks in different areas because we need to get them quicker there because we can't fight the fire with water. So it's changing the whole way industry is working, and we're using data analysis to understand, as this prevalence of electric vehicles and electrical vehicle usage goes up. Heck, my lawnmower, it's got batteries right now. So even there, if I have a fire in the house, it's something that has to be considered. I'll stop there because I could start going further down the road, but I do want to change the session back to Alex to let her talk about something very, very important for you.
Thank you so much. Great session today. What we have following this, just so everyone's aware, we do have a public course that we are running from November 18th to the 21st. You see it here. I'm actually going to share a few links in the chat for visibility for everyone that's on the call today. That link, the first one, it's the follow-on course. We are offering at a heavily discounted rate of 60% off for that specific session. So we hope to see you there and get further insight into the topics here with data science and the ML. And then another thing that we're running, we have 25% off as a thank you for all of you who have attended today's session. That 25% off is eligible for a variety of courses, self-paced, public, private, when training is booked and completed by December 31st, 2024. So promo code TRAIN25 will grant you that discount. I will include that information in the follow-up email I'll be sending. One more thing to note, we are also offering 20% off on our Flex accounts, which helps you really lock in savings for your annual training plan, for your entire 12 months. So really want to take advantage of that as well. So I included a link there to the ExitCertified site for you to get a little bit more details on the Flex accounts, as well as the contact us page for the ExitCertified site if you were to have any training inquiries, and then the email that I had shared prior in the beginning for requesting the slide deck. So all of that information is available at your disposal. I will also be sending a follow-up email again with the recording and this information included. So the last slide here, really just a thank you to you, Kevin, and to the attendees for everyone for joining today.
Thank you, Alex. Been fun. Hope to see some folks in the programs as we go through the sessions all the way through to December and January and next year. It's gonna be fun.
I do have some questions actually coming in. I did say it's for December 31st, 2024 for the 25% off, just as long as you book and complete by. I do think that there's another question, Kevin, in the chat that I might ask.
That's a great question. We're actually doing a lot of upskilling with organizations today where the folks are coming in with backgrounds in statistics. The upskillings are designed to bring you forward and allow you to move into the data science realm with your already existing knowledge. So statistics is a huge area for data science and machine learning, and that's a great question. So yes, indeed, these upskilling programs are designed for those purposes.
Great. Thank you so much, Kevin, again, and thank you all for attending. I hope everyone has a great day. Bye-bye.